properties of a triangle. So in this lesson we're going to be talking about all the properties of four-sided shapes, talking about their lines of symmetry, angles, their side lengths and things like that. If you just pause this video and copy this table out, in terms of completing it, please watch the video as you are completing it, as we're going to be talking about these shapes in more depth. So copy the table out, and then as we're watching the video you can fill in the table as you go along. Okay, so let's start with talking about properties of our quadrilaterals. So what is a quadrilateral? So a quadrilateral, it comes from quad, four, so it's a four-sided shape, so a shape with four straight sides. It cannot have curves or bumps, it has to have four straight sides. They obviously don't have to be equal in length, as long as they are straight and there are four sides to it, then that is considered a quadrilateral. Now, let's talk about naming some of these. So here we've got a square, a rectangle, trapezium. Remember, trapezium can come in a different, not different shape, but it can be drawn in different styles. So this is two types of trapeziums that we can have. We've got a kite, a rhombus, a parallelogram. You'll notice that a rhombus and a parallelogram, a lot of people say that it's a slanted square and a slanted rectangle, so they're quite similar. We've got an arrowhead, which is also called a delta, and an irregular. What it means by irregular, it's basically a four-sided shape that has nothing in common, and we'll talk about that more in depth. So a square has equal sides, so four equal sides, and it has two pairs of parallel sides. So if I was to draw in here, it has two pairs of parallel sides, but all four sides are also equal. And finally, all of its angles are 90 degrees. So if I was to show 90 degrees, remember it's when you almost close in a little box on each corner. So each corner of our square is 90 degrees. Our rectangle, it has two pairs of equal sides, and it also has two pairs of parallel sides similar to our square. And again, all of its angles are 90 degrees. So the only difference between a rectangle and a square is that a square, all of its sides are equal, and with a rectangle, only its parallel sides are equal. So again, if I was to draw my lines, that's what it would look like. And then remember, all angles in a rectangle are also 90 degrees. Our trapezium, it has one pair of parallel sides. Remember, when we're doing the area of a trapezium, the pair of parallel sides, which are those. Our kite has two pairs of equal sides, so that's going to be this side and this side. I'm just going to change my colour. And then we have that side is also equal to that side. It has no parallel sides. Our rhombus, very similar to our square, has equal sides, so all of our sides of our rhombus are equal. Opposite parallel sides, so basically what it means is that the opposites are parallel. So if I was to draw that, like that. And opposite angles are equal. Now it's really important that when your diagram that you draw this and maybe use a different colour. So this angle is equal to this angle, and I'm just going to change my colour. And then this angle is equal to this angle. A parallelogram, again, has two pairs of equal sides, very similar to our rectangle. Opposite sides are parallel and opposite angles are equal. So again, similar to that rhombus, this angle is equal to this angle. And then this angle is equal to this angle. Our arrowhead, it contains a reflex angle. So remember, inside our reflex angle is bigger than 180 degrees, so it's that angle in there. And adjacent sides are equal. What it means that these points here are equal. And our irregular quadrilateral, none of the other ones. So it basically means that there's nothing that these have, this one has. The reason for it is completely irregular, so all of its four sides are not equal, all of its angles are possibly not equal, all of its angles are not equal, and there are no parallel sides on this shape. Now let's talk about lines of symmetry. So how many lines of symmetry does each quadrilateral have? So our square has 1, 2, 3, 4. So that's 4 lines of symmetry. Our rectangle has 1, 2 lines of symmetry. So you'll notice that because our rectangle our 4 sides aren't equal, only the 2 opposite sides are equal, it means that you can't split the shape diagonally, because if you were to split the shape diagonally and then fold it in half, they wouldn't be equal. Sometimes it's easier if you have something that's rectangular shaped, so a piece of paper, and try and cut these shapes in different sizes, bend them in different ways and see if they're equal on both sides. Our trapezium, that one has 1 line of symmetry. However, our other style of trapezium does not have any. So only this one has 1 line of symmetry. Our kite has 1 line of symmetry. Our rhombus has 2 lines of symmetry. Our parallelogram doesn't have any lines of symmetry, because if you have a look at our rectangle, has lines of symmetry going straight down the middle and then again down the middle horizontally. But because our parallelogram is slanted, if we were to fold it down the middle, our edges wouldn't meet, and fold it down the middle vertically, again our edges wouldn't meet, and then we couldn't go diagonally because our rectangle can't go diagonally either. So our parallelogram has no lines of symmetry. Our arrowhead has 1 line of symmetry, and obviously our irregular quadrilateral has no lines of symmetry whatsoever. Now, rotational symmetry. How many times does the shape fit exactly in itself? Count as it spins. So rotational symmetry is basically, as you're spinning your shape, how many times can you fit it into itself? So have a look at the square, pay attention. If you need to rewind and play it again, it might help. So our square goes 1, 2, 3, 4. So from its starting point, I'll do it again. From its starting point, pick one corner and see how many times it fits into each corner. So we've got 1, 2, 3, 4. So that one has 4 rotational symmetry, or rotational symmetry order of 4. Our rectangle got 1, 2. I'll play it again. So pick a corner. It goes into it once and twice for when it goes back to the beginning. So that's got order of 2. So 2 rotational symmetry. Our first trapezium, you'll notice, has no rotational symmetry. There is no point where it is exactly the same and fits into itself. Our other trapezium, exactly the same, also has no rotational symmetry, does not fit into itself. Even though it goes round and fits into itself back at the beginning, because it's only once, it does not count as rotational symmetry. It has to be 2 or more. Our kite, again, has no rotational symmetry. Now have a look at your rhombus. Again, pick a corner and have a look at it. So it goes in once, twice. Okay, I'll do that again. Pick a corner, goes in once, twice. Okay, so remember what I said. These, even though they fit into itself once because it's back to its original shape, it's caused it to have no rotational symmetry because it has to be 2 or more. Now have a look at our parallelogram. Goes in once and twice. So it's got order of 2 rotational symmetry. Our arrowhead is 0. There's no rotational symmetry, only once. And then our irregular, again, only fits back right to its beginning, so it has no rotational symmetry. Okay, so make sure that you've filled in your table, rewind and go back if necessary, and I'll be revealing the answers. So hopefully you should have been able to fill in your table. It should look something like this.